Hello everyone and welcome back to my channel. In this video, we are going to study the advanced topic which is list processing, and we are going to see how we can perform searching of any element in our list. Now, searching is a technique of quickly finding a specific item from a given list of items, such as number in a telephone directory. And depending on the way the information is stored for searching a particular record, search techniques can be categorized into two categories. The first is the linear or the sequential search, and the second one is the binary search. So let us look at them one by one. Now, talking about linear or sequential search. Linear search is a very simple search algorithm. In this type of search, a sequential search is made over all items one by one. Every item is checked, and if a match is found, then that particular item is returned. Otherwise, the search continues till the end of the data collection. On your screen, there is an example. I have taken a list which has certain numbers. Make a key note that here the numbers are not sorted. Now, if we want to search an element, let's say 10, and that point of time, what we are going to do is compare 10 with each element one by one. That is why the name is sequential or linear. So, in the first iteration, 10 will be compared with 45. Here, certainly 10 is not equal to 45, then the search continue. Next, the 10 will be compared with 72. That is the second item of your list. Now, it is certainly not equal to 72, hence the search continue. This time 80, hence again there will be a comparison with the next item, that is 26. Here also we didn't find 10, then 34. Here also we didn't find 10, then 54, then 90, and then 60, and finally at the end now we are at the number which is 10. So you can see that in sequential search we are searching each and every item. That is, in the worst case, suppose I wanted to find out 75, which is the last element of my list, then I have to make, let's say, 10 comparison, because this list has 10 elements. Now suppose 75 was the 100th element. The list may be of 100 items, 10 items, millions of items can be there in a list. So linear search, in order to find that particular element, I have to go through all the elements sequentially. Now, which is the biggest disadvantage of this type of an algorithm? And in order to overcome that algorithm, we have another topic which is binary search that we are going to see in the later half of this video. But first, we are going back to our Python screen and code the linear search program in Python. So for linear search, here I will be defining a function, and the name of that function I will be keeping as let's say linear underscore search. The name of the function should be such so that you can make sure that what you're going to do by that function, that the programming should be readable. So it is going to take two parameter. First is the list, and the second one is the key that you are going to search, right? So colon and then the body of your function. Now this time what we are going to do, we are going to sequentially search each and every item. That means I will be sequentially searching my list one by one. So it is better to use a for loop for I in range, and that range will go to till the end of my list, right? So up till the length of my list, right? So that will be the range of the for loop. Here in each iteration, I will be corresponding to each element of that list, right? So that is the for loop. Now what we have to do, we have to make the comparisons. So if my list I, that is the item at the ith index, right, is equal to key, right? So this is the comparison. Now that is the comparison that we are making with 10, with each element, right? So here with each element I'm going to compare the key, right? So key is the variable that will be holding 10 in it, right? So now if that happens, what you will be doing, you can return true. Now true is a Boolean value, and you can successfully return true through the return statement of your functions. Otherwise, if it is not the case, then what this function is going to return? Then the function is going to return false. That means if I found the key at that point of time, this will be capital K, because I have taken capital K over there, right? So if the value is found, then it will be true, and if the value is not found, then the function is going to return false, right? So now let us make the driver code of this particular function. So I need one thing, which is my list. So let me here define a list in itself. You can also make users to enter the list with the help of the append function and so on, but I'm just taking it a simple example. So let's say 24, 56, 76, 49, 43, 23, 11, and let's say 10, right? So this is my list. Next thing that we want is a key. Let the key also this time be 10, that is the last element, no issues. And now what I'm going to do is I will be calling this linear search function as a condition. Now I can do this because the function will be evaluating to either true or false, and if conditions are also evaluated to true and false, so that can be taken over here successfully, right? So I will be calling this function on my list and on the key value, right? So I'm calling this function over here and colon, and I can write the print statement. If I found the element, I can write found, and if I didn't find the element, I can go with the else keyword and printed not found, right? So let me just run this code and verify whether it's working fine or not. So on your screen, because 10 is the part of this list, I got found printed. Now the next thing is, maybe if I want to know the index value where this particular 10 is actually located in my list. So in place of true, what I can return is I, which is the index, and in place of false, I can return -1, because indexes are actually positive values. So here I can do is, if maybe calling the function into a variable, which is this, and linear search, and then I will be calling it on my list and key, right? So this is, I've just called the function, and if the value of s is equal to is not equal to, actually, if it is not equal to -1, right? If it is not equal to -1, then found at, let's say, I plus 1, right? And else, because if it's -1, then it's not found. Very fine, right? So let me just check it, the value. This is 0, 1, 2, 3, 4, 5, 6, and 7, right? So it's at 7, right? So let us run the code and see. I is not defined. Okay, so it should not be I, this should be s plus 1. Let me just clear the code, and now, and you can see that it's found at 8th index, because it's starting from 0 to 7. So if you want to get 7, you can simply do it as 1, and you can get found at 7th. If you are taking the indices from 0, so it will be 7, otherwise it will be 8. So that is how we have made actually the function of linear search in Python. I hope that you understood this particular program. Now let us go back and understand the concept of binary search. Now talking about binary search, now this is a concept that is based on divide and conquer technique, which is going to eliminate the disadvantage of linear search, because when we have a lot of items or the lot of elements in my list, then at that point of time linear search will going to take considerably a lot of time, right? So timing in programming is a very, very important concept, even the execution time as well as the time complexity. So in the both this situation, binary search is an algorithm which is working better than linear search. So let us understand that how binary search works and how it is a better approach. Now, this search algorithm definitely works on the principle of divide and conquer. Now, this algorithm, in order to work properly, there is one condition, that is the collection, that is your list, should have sorted elements. Now, how this actually works? Binary search looks for a particular item by comparing the middlemost item of the collection. Now, if the match occurs, then the index of the item is returned. Otherwise, because of the comparison, we are getting to know whether the item, because the list is sorted, we know that whether the item will be in the left hand side or in the right hand side of the middle element. Depending upon the situation, we discard the half portion of the list and search either in the left portion or in the right side portion, right? And this process continues on the sublist or the subarray until we have find the element or the subsize reduces to 0. So let us take a look on an example and understand how it works. On your screen there is a list which have 10 elements indexed from 0 to 9. So what is the first step that we actually perform in binary search is calculating the middle element, right? So in order to calculate the middle element, we make use of this particular formula, which takes 0, which is the lowest index, and 9, which is the highest index, divide by 2. I have taken the floor operator because I want the values to be an integer after the calculation. So you can see that 4 is the index that is present in the list, and the element at 4th index is 33. Now, the next thing is we want an element to be searched. Now, the element to be searched is, let's say, 67. Now, what is the next step is to compare 67 with the element which is present at the middle index. So here 67 will be compared with 33. And clearly 67 is greater than 33. Therefore, the search will be conducted in the right hand side of 33. Now, this is where the essence of binary search lies. You know that the numbers taken in the list for performing binary search are sorted. When the list is sorted, therefore, there is no probability of finding 67, which is coming out to be greater than 33 on the left hand side. So there is no probability of finding 67 on the left hand side of 33. Therefore, what we are going to do, we are going to discard the left side of your list. And then we will have to, left over with the right hand side, which is having the index from 5 to 9. You can see it from the previous slide that 33 is actually at 4, right? So now the leftover portion will be from 5 onwards, right? So now the leftover list is from 5 to 9. So we need to notice that now the value of low is mid plus 1. Mid was 4, right? And now the lowest index is 5, that is mid plus 1. If it would have been the left hand side, if we have searching the left hand side, if the value is less than middle value, then the search will be conducted on the left hand side. Therefore, we need to modify the highest index to as mid minus 1, right? So that is something essential which we are going to use in the programming. So now this is the leftover list, and we are again going to calculate the middle value on this. That is, binary search will be actually acting recursively, right? So now the lowest index is 5 and the highest index is 9. On calculating, I got 7, and the element at the 7th index is nothing but 67. So it is equal to 67, the key to be searched, and therefore the search is successful. So that was how, we have discarded the half portion of the array. The elements are actually cut down by half, therefore reducing the number of comparison. Here we are only comparing the element with the middle element, whereas in the linear search, we have to compare each and every element with the element to be searched sequentially. Therefore, binary search have a better performance than linear search. Now let us go to the Python screen and see how we are going to perform the programming of binary search in Python. For now, I do not need this particular code for linear search, but I'm not deleting it because I will be using it and showing you how there is a comparison between the search time of linear and the binary search, right? Now making the code for binary search. Here again, I will be making a function whose name will be binary search, and again over here I will be taking as the parameter my list and key, right? So in the body of the function, what I'm going to do is declare a variable which is low, which is going to indicate the first index of my list, and another one I will be taking as high, which will be indicating the last index of my list, and I will be passing it to the function that is length of my list and -1, because I have actually started the indices from 0, right? So this is where I have defined the indices of my list. Now this is because over here we are going to find out the middle index of the element. Now that is what the working of your binary search is like. So here I will be taking a while loop and I will be checking that the lowest index should always be less than or equal to the highest index. This is something making sure that over here there are certain elements present in my list, right? Only then this binary search will be going to work. So what I'm going to do is I will be finding out the mid element, right? And over here the mid will be equal to low plus high. And because you have seen that in the slides I have make use of floor function, and in Python in order to emulate floor function we make use of the floor operator, right? So here we have calculated the mid, and this time we have make sure that mid contains a integer, right? Because indices are whole numbers, that is integer, they're not in fractions, so we cannot afford to take in points the value of mid. So we have taken the floor operator. Now the if condition. Now if my list, the element actually which is present at the middle one, now this is the comparison. Now we have the mid one, now we have the value of key. So what we are going to do, we are going to compare the element at the mid index equal to the value of our key. Now if that's so, now if that is the condition, then what we are going to do is return the mid, because if the element is found at that index, now that is the actually position of my element, so my work is done over here. Now what if that doesn't happens, right? At that point of time what we are going to do is we will be taking another condition which is else, and inside else I will be making a use of if. You can also use else if elif statement, but here I have taken this particular zona, right? So if the value of key is actually less than the item that is present at the mid index, right? Now if that's so, what we are going to do is we will be modifying the indices of high is equal to mid -1. You know that we need to actually discard either the left side or the right side, right? So when we will be discarding either of these sides, right, one of the sides actually, then we have to modify the indices accordingly. So that is the same thing. And else what happen otherwise, if that is not the case, what we need to do, we need to modify the lowest index, and that will be equal to mid +1, right? So that is we have modified these indices. Now if all the conditions didn't work, then what we need to do is we will have to return -1, because if I got the element, then I will be returning the index at which the element is there. Otherwise, what I will be doing, I will be returning -1. So now this is going to actually act as, if the element is present, then I have an index, otherwise I have a negative value. Now, in order to run the code, what I need a value of a list. So let me just initialize a list with certain numbers. Let the number be these, right? Then I need a key value. Let me just define the key value as 8 this time. And what we are going to do is, because the function is returning something, so I will be assigning the function to a variable, copying the name from here so that there should not be any errors, and now passing the my list name and the key as the parameter. And after that, what I will be checking, if s is not equal to -1, at that point of time we are going to print element is found at index, and the index value will be, let me just convert it into string, and the value will be s. Otherwise, if that will not be the case, and then I will be printing, if the element is not found, element not found, right? So that is something about binary search. Now let me just run the code and verify whether it's working correctly or not. So if I run the code, you can see that 8 is found at index number 4. So let me just check. So 1 2 3 4 5, right? So it's 0 1 2 3 4, right? So it is at index number 4, and if you want the indices to be at actually 1, that do not convert it into a string and let it be s only, right? And run, then you can see that the index is 5. So you can work at accordingly. Now if I check about 9, so that should be at index number 6. So now the function is working very fine. So that is how we have seen that how we can actually program linear search and how we can program binary search. Now one more thing which I really wanted to tell you is, and which is something really very important, is the time taken by these two algorithms, right? So let me just do one thing. Import over here, import timeit. Now this is a module in which, or with the help of which, we can calculate the time taken by each execution of a single code, right? So for that, what I will be doing is, let me just make it over here, right? So what I'm going to take is, I will be taking a variable which says time taken by ls, which is nothing but the linear search. So what I'm going to do over here is, I will be calling timeit dot timeit method. Now there is a difference. You can see the color coding. Timeit is a module which I have imported over here. So this is a module, right? And this is a method or a function that is available in that module. So what this timeit function did is, or what this timeit function do is, it takes certain parameters. Now I will be using two parameters over here. The first parameter is statement. Now what it takes? It takes the complete executed code, complete executable code in form of a string. So now you can understand that why I have actually commented this particular linear search program or a function. So here I will be here what I will be doing, I will be taking a variable called ls, and I will be assigning this particular complete code to ls. Now what that does, it signifies that this is a complete executable code. You have seen, I have already run this. I have actually executed it and seen the answer. Now this is a string now, right? In triple quotes. And this I will be going to pass over here. Now this is a program whose time of execution I want to calculate. Now, how many times I want to run this program. Now that will be actually provided by number. So how many times I want to run this code? 1 times, right? So through this particular statement, what I'm going to calculate, what is the time taken by one execution of linear search. Now similarly, what I'm going to do is I will be taking a variable called BS, and I will be making this as the complete code, the complete executable code as a string, right? And what I'm going to do is I will be using the same code over here, but in place of ls I will be making it as bs, and I think that is, yes, that is in lowercase, so that will be ls, right? And in place of bs I will be ls, I will be doing this and like this. Now what I want to do is I will be adding a print statement and say time taken by linear search, and the time is time ls, so comma time ls, and copy this again, paste it over here, time taken by binary search, and this will be D, right? So let me run this code and compare the time taken by the both algorithms. And before that, what I'm going to do is I will be using the same inputs, right? Because here the inputs are different. So let me just paste it over here, and I think the key was 9. Right. So now I have actually make the inputs also the same. And if I run this code, you can see that actually the code will be get executed, and this will be checking over here is now the time taken by linear search is this much. And you can see that there is a this number is not 9.9 actually. This is something in power of exponent, right? So that is a very small number as compared to the time taken by the linear search, right? Because it is actually something a considerable number, so which is it is not using this particular way of working. Let me just actually just make a small array and run it now, and let the element be 3, and here also let me just make it a small number, and the element is 3, right? So code on executing the code now, if I now clear it the screen, and here if I run the code now, even now you can see that it is a very small number. That is why it is coming actually at the exponent value, right? So this is not 8.9. Just make sure that this value is a little less than the above value. So it is clearly seen over here that linear search takes a lot of time as compared to binary search, right? So that was all in this video, where we have seen that what is binary search and what is linear search, and we have also programmed it and check it through the time it module, the time execution of both the algorithms. I hope that you like this lecture, and for more such videos, stay tuned to my channel. Thank you.